So the talk that I want to give tonight, I often have questions about all the different auth flows. So a lot of the ones, if you're familiar with authentication flows with OpenID Connect and OAuth, you might have heard of Implicit Flow and Authcode Flow. They're the two main ones. But then there's a whole lot of others, and there's reasons why you wouldn't use Implicit anymore. So I thought I'd create a presentation that goes through and describes the 5 main auth flows, the ones that you can see there. So we've got Implicit Flow, Device Flow, Authcode Flow with PKCE. And PKCE is a proof key for certificate exchange, and basically that's similar to what the auth code is in the Authcode flow. It's basically a cryptographically randomized code that gets sent from 2 different perspectives in order to make sure that the person who's requesting the certificate or the tokens or the device that's requesting those is actually the device. We'll see that with the flows. And client credentials flow, which is probably one of the simplest but often overlooked ones. Okay, let's get started. So Authcode flow, this is probably the most complicated one, but the one that anybody who's doing front-end, back-end kind of development, as opposed to single-page app, if you've got a front-end or back-end in your web application and you're using some kind of identity provider for your authentication, this is the one you'll be familiar with. So what happens is you've got your browser on your left, you've got your application, your web application up on the right, and you've got the identity provider down at the bottom. What happens is somebody comes along and they make a request to your web application from the browser. The browser at this moment doesn't know who you are, so they're going to have to ask you to log in some way. So what happens is, so the solid lines are things that you can see, and then we've got a dotted line that will come up in a second, and this is a redirect. So we have on the right-hand side, the server will return back a redirect request to the browser, and it will include in there 2 items. And we've got the client ID, and then we've got a set of scopes. So scopes are kind of like options. When you make a request for any kind of information about identity, you've got options that you can request, like do you want it to be an OpenID Connect authentication? Do you want to get the email address? Do you want to get the profile information for the user when you get the ID token back? So that's what the scopes are. The client ID is basically an identifier for your web application. So if you have a web application and an iOS app and an Android app, you might have 3 different client IDs, depending on which system is asking you to log in at any one time. That redirect is a redirect straight through to the identity provider, and the client ID and the scopes are sent through. This allows the identity provider to know which system you're trying to log into and what kind of options you want with that login process. So often you'll log in with Facebook, for example, and it says this site wants access to be able to post to your post to your wall. That kind of thing would be extended kind of options that you get. So at this point here, the identity provider, there's a tiny little gray arrow there that you might or might not be able to see. That's basically the login. I'm not going to worry about how you log into the identity provider, but at this point, if you haven't logged in before, it's going to ask you for your username and password or whatever kind of credentials. But we'll assume at this point that you're already logged in on this server. So what happens is we get a redirect straight back to your browser. Your browser at the moment is still making this initial request to the web application you're working on, but it sends back the auth code. So this is the cryptographically randomized code. It doesn't really, there's nothing in there that tells you who the person is, what you're trying to log into, where you are in the world. There's nothing in it. It's just a random piece of garbage that can be used later to look you up. And that token then gets redirected straight back to your web application. So at this point, your web application has received a request from you for some kind of resource, and through this redirect process now has an auth code. So with this auth code, it can make a request directly to the identity provider. So we're cutting the browser out here. Remember, the browser in 99% of the case is a totally untrusted environment. You shouldn't trust anything that comes from a browser, because it could be somebody on a curl command line. It could be somebody like we just saw in the last talk hacking the cookies and sending information. We can't trust what comes through. So what we do is we take the client ID and the auth code that were brought back from the auth code that was brought back through the browser, but we also sent through the client secret. And this is almost like an API key. Your web application will send that, only ever send that to the identity provider. And it's basically the way of your application saying, I'm talking to the identity provider and I am authorized to make a request for more information based on this auth code. So the identity provider can then say, well, that auth code that we had, 1, 2, 3, 4, I randomly generated about 25 seconds ago for Ben, who just logged in. Therefore, I'm going to manifest some kind of token for Ben, and I'm going to return that back to the application that made the request. And there's 3 tokens, usually definitely 2, sometimes 3 tokens. First one is the identity token. So this gives you information about the person that's logged in. It might be their name. It'll certainly be a subject, which is a fixed value that you can then rely on in your web application to use essentially as a foreign key against all of the entities that you have in your database or whatever kind of data store you have, so you know who that person is. Every time that person logs in using the same credentials in the future, you will always get that same subject back. And there's other bits of information in there as well, like the expiry. Maybe there's a URL to a photo of me, whatever else. The second one is an access token. So this is basically a token that your web application can use to talk to other APIs on my behalf. And that access token will also have certain scopes on it. So you might have an access token to talk to Contentful, which is like an API-based CMS tool, in order to be able to read information but not create new web pages. So then your web application can talk to another API on my behalf using that access token. And the third one there is a refresh token. And this is only ever provided if you request offline scope. So one of the scopes in the original request there, this never works on screens. That one there. So one of the scopes can also be offline. And if you make a request for an offline token, it means that your web application can talk to the API on my behalf, even if I'm not logged in, even if I'm logged out specifically at that point, not at my computer. So in that case, an access token would potentially expire fairly quickly. You typically have an expiry on an access token of, I don't know, maybe a minute, 5 minutes, 10 minutes. It's usually quite short. But if you want to schedule a tweet for tomorrow morning at 7 a.m., that access token is going to work for you anymore. But you can use the refresh token as the web application to get a new token to be able to send a request to Twitter to make that post. So those are the three that you'll get back there. And then using that access token, so that'll end, line 8 is the response back to the browser. So this is the initial request that you made. The web application now knows who you are, and it can return whatever you requested. But separately to that, it also has that access token now, which you can send off to some other API, which is what we were talking about, making requests on your behalf. So that's Authcode flow. Makes sense, right? I thought I'd start with the most complicated one first. It gets easier from here. So let's have a look at implicit flow. So this is typically, what you would use for single-page apps. In a single-page app, you've got an application running in a web browser, and there is no back-end. I mean, there are going to be APIs that you talk to, but there's no real stateful connection between a back-end and the browser in the way there is with a traditional server-based web application. It's all running within the browser, which means that all your business logic is in the browser, and all the information about how to connect to other APIs is in the browser. There's no safe place. Remember before I was saying that a browser is essentially always insecure? We can't trust anything that comes from a browser. We also can't trust anything that runs in a browser. We've got cross-site request forgeries and cross-site scripting attacks. We also have unknown issues or issues with what browser plugins are doing. A browser plugin has access to what's running within the DOM of every single tab that's open in your browser. If you write an application, a single-page application, and you use NPM as your package manager, and you're including, I think the statistic is that an average NPM-based browser application is 94% code written by other people. There's no way we're going to audit all of that 94% of the code. So there's going to be something running in there that you're not expecting. So we can't trust the code even that we deploy. So given that, we have to assume that our application is running in a completely hostile environment, and we don't even know what's in our own code, even if we're the only developer. So the way that implicit flow helps us is it allows us to make an authentication connection to an identity provider without the need for a server to do that Authcode flow check. And it does that by inserting a huge big security hole, which is sometimes okay to have. So the way this works is we make a request directly to the identity provider to log in. So you will then log in on the identity provider. Assuming you're logged in already, the response to that is basically a callback to your application that provides the three tokens directly, or sometimes just the 2 tokens. In fact, in implicit flow, you're probably not going to use offline mode, because the single-page app is never going to run offline because it's in your browser. So you probably won't get the refresh token in that case. Private number is calling me. Excellent. Go away. Hang up. So that's how that works. Really nice and simple. Also a little bit of a security hole in that anything that's running within your application can now access the tokens that have been returned. because typically they're sent back via a callback, which can be intercepted by any JavaScript running in your site. And also, if the recommendation is not to store those tokens in local storage or in cookies, because obviously they can be accessed by any other JavaScript running in the application. Again, cross-site attacks can then get access to that. The recommendation is to store it just in a variable, which means if you refresh the web page, you're going to have to get those tokens back again. And there are ways to do that cleanly without affecting the user experience of the login process. But it's still possible to do a memory dump from JavaScript and get all the information out and look for anything that looks like a JSON web token. So this has now been superseded. This was just about 4 or 5 months ago, I think, with the new flow, which is Authcode flow with PKCE. So this is the proof key for certificate exchange that I was mentioning. The Authcode is kind of like that. So what we do is we take the benefits of Authcode flow and we apply those to a single page app scenario. So we still make a request to log in, and in this case we pass in the client ID. This identifies to the identity provider who's logging in. We also send through a challenge. So this is basically within the single page app, you create a cryptographically randomized string and then you hash it. We'll remember that for later. So the response comes back and says, yep, this person is logged in, here's the auth code, and now the browser can send back a request saying, okay, here's the auth code and here's the solution to the challenge that I set. And because both of them know what the hashing algorithm was to create the end result, the identity provider can take the solution, which is basically the unhashed value that was generated in the first place in the single page app, and compare it against the hash value that I sent before. So because unhashing is so hard, it's so extremely unlikely that if anybody did actually find the hashed value and managed to create a request in for the actual tokens based on the auth code beforehand, before you were able to get to them, the likelihood of them working out what the source of that hash was is extremely unlikely. So that then allows the identity provider to say, well, I know that you are the person who initially requested the login because you know the solution to the problem you sent me in the first place. So then it'll return the 3 tokens back. Does that make sense? Cool. And then, of course, the access token can go off to that identity, the API that we can't see anymore. There it is, gone again. Client credential flow, simplest one. I love this one. Anybody heard of client credential flow? Anybody used it? A few of you. Okay, so this is it.
That's what it is, and then we'll tell you we've used it.
Make a request, send the client ID and the client secret, and you get a token back. So there's no browser here.
I've used it.
Yeah, there's no browser here. It's just basically an application. It's machine to machine, basically. An application saying to an identity provider, I need to be able to access this API. So it's not about a person anymore. There's no ID token. There's no, well, there is an access token, but it's not, the access token isn't based on the capabilities of a person. It's based on the predefined capabilities of this machine to talk to another machine. So this API can now talk to that API based on the fact that it has the ability to get a token. So you could argue that you can just have an API key, right, for that. But by bringing the identity provider into the middle, you're providing a centralized place where you can control exactly which APIs are allowed to talk to which other APIs, and also changing in there the permissions. So these 2 APIs might have a pre-existing understanding that this API is allowed to create entities, but it's not allowed to delete them. If you wanted to change that, you'd have to make some kind of code change or configuration change in one of the APIs. If you can do that at the identity provider level, you're keeping that all together, an easier place to manage things. And then the final one is device flow. So this is a pretty, I mean, it's been around for a while, but it's pretty recently come up a lot more, especially with IoT type products. The biggest example of this is where you have, well, there's a fridge there. I mean, that's one example of IoT that doesn't have a keyboard. But imagine you've got a PlayStation and you connect to your TV and you want to connect it to, you want to authenticate to some kind of third-party API in order to get access to information, and you've got to type your username and password in using a PlayStation controller. That's always fun, isn't it? Especially when it's the onboard screen and everybody can watch exactly which letter you're clicking. So security's out the window. So device flow actually allows you to use a different device to log in to another device. So let's take the example here for fridge. Got my mobile phone, which is what I'm going to use to log in, and the identity provider over here. The fridge is going to go off to the identity provider and say, here's my client ID. I need somebody to be able to log in for me. And the identity provider says, yep, sure. So here's some information for you. Let's have a look what's in there. We've got the device code. So this is a code that's specific just to that device now. got a user code and a verification URI. This is where I, as the user with some kind of device, I can go and hit that verification URI, I can provide the user code, and that's the link between my device now that I'm using to log in and the device that I'm trying to authenticate onto the network. There's also usually a verification URI complete, which is like the whole thing in one. It makes it easier for you to use. You can have like a single click, press here type thing. And obviously an expiry. The final thing is an interval. And this is because there's no real connection between my mobile device and the fridge. This is the identity provider saying you should check every 5 seconds to see whether I have a token for you. So that's the interval. So the third one comes back, and we've got a little clock on there because this is a repeating polling kind of request. Every 5 seconds or every 10 seconds or whatever that interval was, the fridge is going to go to the identity provider and say, got a token? And the identity provider is going to say, nope. And that'll happen for a while. In the background, in some way, some information gets passed from the fridge to my mobile phone. This could be in the form of a QR code. It could be in the form of a URL that I've got to type in. And essentially what this does is it passes in the bits of information that I need to close that loop of authentication. So I'll take, for example, the verification URI complete, which is going to be a URL that I can click on, and it'll take me off to the identity provider. So it sends a request through. We're already logged in, so the identity provider knows who we are, is able to generate a token, and then the next time 3 comes along and polls, 6 responds and says, here's your token. So we've now managed to log into the fridge through our mobile phone without the 2 actually being physically connected on a network as such, and the fridge now has a token to be able to talk to the API. Does that one make sense?
Yes.
That's a cool one.
Now I can watch Netflix on my fridge.
Now you can watch Netflix on your fridge. So that's it. Any questions? Happy to take them now, happy to take them afterwards. There's a couple of URLs up in here. They don't work yet because I only just finished this presentation about 3 days ago, but they will if you want to take photos of them or mental notes of them or whatever. That URL at the top there will allow you to download this cheat sheet, and it'll probably be up in the next week or 2. Well, thank you so much for coming.